Okay, now turn to page 22 in your chapter 11 packet, and we're going to go over some operations with radicals. So, for the first one, if you look up at the top, I show you that if you have 6 root 7 plus 5 root 7 minus 3 root 7, you treat this just as if it was 6x plus 5x minus 3x. This thing called root 7, you have 6 of them, you have 5 of them, and then you subtract 3 of them. So this becomes 11 root 7 minus 3 root 7, which is 8 root 7. So you treat them very much like variables. So if you have a 5 root 6 plus a 3 root 7 plus a 4 root 7 minus a 2 root 6, you can't combine your root 6's and your root 7's just like you can't combine your x's and y's. But I can combine these 2 root 7's and I get 7 root 7. And 5 minus 2 becomes 3 root 6. Okay? Now, sometimes it gets a little more complicated than that. Sometimes you might have something like this. 3 root 45 plus 4 root 80 minus 2 root 125. At first glance, it appears as if you can't combine these because none of them are the same under the radical. But then, when I look closer, I realize they can also be simplified. So before I'm convinced I can't combine them, let me simplify them. So this becomes root 9 times root 5, and that's a 3, so this is 9 root 5. This becomes 4, and 80, believe it or not, is root 16 times root 5. So that becomes a 4, so this is 16 root 5. And then minus 2, this is root 25 times root 5. So that's a 5. Minus 10 root 5. Now they're all root 5s. So 9 plus 16 is 25. Minus 10 is 15 root 5. So sometimes you have to look at it and see if you can simplify it before you think you can't combine it. So let's look at B. B is root 200 plus 3 root 5 plus 7 root 2 minus root 18. Again, none are the same, but let me see if I can simplify. This becomes root 100 times root 2, so 10 root 2 plus 3 root 5 plus 7 root 2, and this becomes root 9 times root 2, so minus 3 root 2. So 10 root 2 plus 7 root 2 is 17 root 2, minus 3 is 14 root 2 plus 3 root 5. So now, before you try to combine, you look and see if you can simplify. So let's turn the page and we're going to try C. Now if you want to try C on your own, stop the video, try it on your own, or you can just watch me do it. Now, this just becomes root 5. This becomes 1 over root 5, which I'm going to rationalize by multiplying by root 5 over root 5. So now I have root 5 plus root 5 over 5. Now, they both have a root 5, but they have different coefficients. So this is 1 root 5, and this is 1/5 root 5. So one way you can do is just say this is 1 1/5 root 5. If you see the coefficients that clearly, go ahead and do that. Some of you won't. Some of you will say, well, this is a fraction. I can't combine them unless I have a common denominator. So let's change root 5 over 1 into something over 5. So this I multiply by 5, which means I have to multiply this by 5. So 5 root 5 over 5 plus 1 root 5 over 5. I combine them, that's 6 root 5 over 5, which is really the same as 1 1/5 root 5. Okay, so look at that. Try to do it again if you didn't get it the first time. And when you're done, try to do D on your own. Stop the video and I will do D for you right now. So D has 6 root 7/4 plus 3 root 28 minus 10 root 1/7. So I'm going to change this to 6 root 7 over root 4, which is 2. So that becomes 3 root 7. This becomes 3 root 4 times root 7. That's a 2. So this is 6 root 7. So that's 9 root 7. I'm just getting ready. Now this is minus 10 times 1 over root 7 times root 7 over root 7. So this becomes minus 10 times root 7 all over 7. So I have 9 root 7 minus 10 root 7 over 7. So what I'm going to do now is change 9 root 7 to become a fraction that has a 7 in the denominator. So 9 root 7 over 1 equals what over root 7? Well, what over 7? I have to multiply my denominator by 7, so I have to multiply my numerator by 7. 9 times 7 is 63. So this is the same as saying 63 root 7 minus 10 root 7, and that gives me 53 root 7 over 7. And again, if you didn't get it, try it again, look at it until you did get it. Okay? Now, looking at the next example, we're just going to practice some multiplying with radicals. Now remember, radical multiplies radical, number multiplies number. So when I multiply 2 root 10 times root 5, it becomes 2 root 50 plus 3 root 6. Root 50 can be written as root 25 times root 2. So that becomes 10 root 2 plus 3 root 10. Sorry, I don't know why I wrote 6 there. 5 times 2 is 10. So this is 10 root 2 plus 3 root 10. Okay? Now, 5 root 2 squared. Okay, I showed you how to do that. So you can just go ahead and look at that. And then you go ahead and try number 1 and 2 on your own, and I will do it for you. So stop the video if you're doing it on your own. So root 6 times root 3 plus 5 root 2 becomes root 18 plus 5 root 12. Let me just erase that. That's 5 root 12. Okay, because the root 6 multiplies the root 2 for root 12, and 5 is there. This becomes root 9 times root 2 plus 5 root 4 times root 3. That becomes a 2, that becomes a 3. So I have 3 root 2 plus 10 root 3. Now, number 2 is 3 root 5 squared. So it's 3 root 5 times 3 root 5, which is 3 times 3 times root 5 times root 5. 3 times 3 is 9. Root 5 times root 5 is 5. So that's 45. Okay, so now we're going to turn the page and we're going to go over how to simplify a radical with conjugates. So turn to page 24. And let's look at number 1. We have 2 over 3 plus root 5. Now, if I multiply this by root 5 over root 5, I am not clearing the denominator of a radical because I'm going to end up with 3 root 5 plus 5. So the way you get rid of a binomial in the denominator is you multiply by what's called the conjugate. And the conjugate is the same numbers but connected with a different sign. And a lot like what happens with the difference of squares, your two middle terms are going to drop out. So this becomes 3 times 3 is 9. 3 times negative root 5 is negative 3 root 5. 3 times root 5 is positive 3 root 5. Minus root 5 times root 5, which is 5. These two terms cancel out. You have 9 minus 5, and your denominator is 4. Your numerator becomes 6 minus 2 root 5. Okay? Now, we're still not done, because if we look at 6 minus 2 root 5, I can factor out a 2, which makes sense because originally we had a 2. So let's go back to having 2 times 3 minus root 5 all over 4. Those cancel out. Your answer is 3 minus root 5 over 2. Okay, so let's look at number 2. We have 1 over 4 minus root 2. Now, to get rid of this, I'm going to multiply the top and the bottom by 4 plus root 2. Notice it's the exact same numbers, but a different sign. The result is you multiply 4 times 4, which is 16. 4 times root 2 and negative 4 times root 2 will drop out, so I ignore them. Minus root 2 times root 2 is minus 2. So this becomes 4 plus root 2 over 14. Okay, let's try another one. Let's try number 3. So number 3 is 3 over 5 minus root 3. So I'm going to multiply both the top and the bottom by the conjugate, which is 5 plus root 3. 5 times 5 is 25, minus root 3 times root 3 is 3. The top becomes 15 plus 3 root 3. So this equals 15 plus 3 root 5 all over 22. Okay? Now you can try the rest and then check the answers on Google Classroom.